Okay, this is Mr. Green again, and this is another in my series of geometry lessons. And I know you're getting tired of this unit, okay? And, we've slept, and it's really making me upset that we have to go into another concept of this one. Indirect measurement, additional similarity theorems. Mr. Green, I'm getting so tired of dividing these triangles up into different ways and just seeing where the ratios are. Let me just tell you that almost every side that you come up with is going to be in ratio and proportion to some other side. But you got to be careful. Not everything is. You got to make certain you know it's one of the similarity theorems that we're looking at. This one is dealing with altitudes. Altitudes are going from the vertex down to the side, making a 90-degree angle. And they're telling you that the altitudes are in the same proportion as the sides are in proportion to each other in similar triangles. So just looking at that, that's a little help. This one is medians, and a median goes from the vertex down to the other side, and it meets at a point where the side is divided in half. And in this particular case, they're telling you that the medians are in the same ratio as the sides are in ratio. So that works out very nicely in that respect. Let me give you a couple of example problems. Here I've got a triangle. We don't know the height of this altitude. How did I know it was an altitude? 90-degree angle gave it away. Okay? So, don't know the height of this altitude, but I can see the side and this one both are numbers, and they're going to be in ratio to each other. So 24 over 8, altitude on this one 6, x over 6, set it up, solve it, x8 equals 18. Okay, simple enough. This one is the median one, where I've got sides that are a side that's divided in half. See how these things are equal to each other, divided in half. From that point back to the vertexes. Cool. Well, that means this is a median. That's one of those that we can set up. And I can say that 12 divided by x is equal to 14 divided by 6. And when I solve that, I get approximately 5.1 centimeters. Okay? Cool. Here's one where we've got, well, it's not an altitude, it's not a median. Oh, I think this is just one that we've looked at before, where we've got side splitting theorem. But you know what? We're now using those ones that we're coming across that were parallel, aren't we? We weren't using those before, but we can use them. That's what I'm telling you. 26 divided by 20. 26 and 20. Now what I want you to recognize is this 20 is the side of a triangle, isn't it? So I've got to use that side of the triangle, 2x plus 4. And this 26 is the side of a triangle. So I've got to use the whole side of the triangle from J to L. Well, they didn't give me J to L. They gave me N to L and J to N, so I can add those together. 2x plus 4 plus 3 is 2x plus 7. That's where this came from here. Okay? Now it's just a factor of doing our means and extremes, and when we multiply these out, divide by the numbers, combine like terms, divide by the numbers, we get that x is equal to 3. Okay? That wasn't that difficult. Plug x back in. 2 times 3 is 6 plus 4 is 10. So this side down here, Jn is 10 and Jl is 13. Woohoo. Okay? Here's one. See how we got these little red lines here? Telling us that these are equal. That means this is a median problem. So 20 divided by 8, 2x plus 5 divided x minus 4. Solving that simply by using means and extremes, we get x is equal to 30. Woohoo. I'm not going fast on these, but you can rewind them and watch them again, okay? This one is called an indirect measurement example. It is a perfect situation that we could actually see this in action. Here we've got a flagpole. We don't know how tall the flagpole is. Okay, we've got some sort of a flag on this flagpole. Okay, flag up here flying. They want to know how tall the flagpole is. they happen to notice that the shadow that the sun cast, okay, sun up here, shining brightly, sun, it cast a shadow. Flagpole shadow happens to land right here. And this street sign sitting right here between the flagpole and this spot, it also casts a shadow that lands right here. We can measure the street sign, it's 4.8 feet tall. We can measure the distance from the shadow into the shadow to the street sign, and that's 6 feet. And we can measure the distance from the sign to the flagpole. That's 19 feet. But we're talking triangles, so I need to add these two together to give me the total of 25 feet. Because now I can say that 4.8 divided by x will be equal to 6 divided by 25. Where'd the 19 come into play? I had to add that to the 6 to get the whole length from here to the flagpole. Okay? That's where that one came into play. And when you solve that down, you're going to get this 20 feet tall. So it's a 20-foot tall flagpole. Okay? This one is where you've got Alexandra sitting here with a flashlight. And she shines the flashlight down onto the ground. Right? The light comes down on the ground and hits a mirror. And it starts going back up. What we're looking at here could be done with pool balls or with anything else. It's called the angle of incidence. The angle that this light made with this line would be equal to the angle of reflection. Okay? That means that this angle in here is equal to this angle in here is what it actually means. Okay? That means I've got proportional triangles, guys. I've got one angle and a right angle, one angle and a right. I got angle-angle similarity. That means we can use these proportions, can't we? So we're wanting to find how far it goes up on the wall over here. I can say 2.5 divided by x will be equal to 4 divided by 10. 2.5 divided by x is equal to 4 divided by 10. And when you solve that down, you're going to get that x is about 6¼ feet high. Woohoo! We found the height up on the wall. Okay? This one says that if I take a triangle and I bisect an angle, you bisect, that means divide it in half equally. Okay? So the angle is being bisected. That they're telling you that this line that bisected the angle will be in proportion to the sides of the two things. So the two bisected lines, two sides. That's what you're going to wind up with. Okay? So here's an example of it. I've got a bisector here. We don't know how long it is. Okay? But we do have the side measurements on two triangles and the bisector on another triangle. So we can say 18 divided by 4.5 will be equal to x divided by 3. Solve it. Not that hard. Means and extremes. Okay? Here you've got another one. You know the bisector length is 10 on this one and the other one is 14. So you can say 10 divided by 4 is equal to 3x minus 1 divided by x. Means and extremes, 10x, 12x minus 4. Subtract the 12x, you get minus 2x is equal to minus 4 divided by the negative 2, x is equal to 2. Woo-hoo. Another example of it, we've got the bisector is 4 centimeters, and this one is x plus 6. Well, I can say 4 divided by x plus 6 is equal to 9 divided by 15. And when I solve that out, 9 times x, 9 times 54, 4 times 60, subtract the 60, I got 9x equal to 6, x is equal to 2/3 of a centimeter. That means that this distance here is 6 2/3 centimeters long. Okay? This one says proportional segment theorems. It says an angle bisector of a triangle divides the opposite side into two segments, and these two segments have the same ratio as the other two sides. This one is quite interesting and very, very useful. Okay? So if I've got this angle bisector that came along here, divided that angle in half, I can take this, the 12 and the x, and say that they're in proportion to the 16 and the 20. So 12 divided by x is equal to 16 divided by 20. Solve down, x is equal to 15. Same sort of thing. 7 divided by 5 is what they wrote. 7 divided by 5 is equal to 2x minus 4 divided by 8. Means and extremes, right? 7 times 8 is 56. 2 times 5 is 10x. 5 times negative 4 is a negative 20. Subtract, add the 20 to both sides. 10x is equal to 76. X is equal to 7.6. So we found what x is. Can we find this side over here? Sure, that's 14. 15.2 minus 4, that's 11.2. Woohoo. Okay? Once again, we're told lengths on some sides, 26 and 32, angle bisectors. Okay? That means these are in proportion to each other as well. Wait a second, that doesn't match this problem, does it? That was this other problem over here. So scratch this stuff here. That doesn't make any sense. What do we get here? We get x plus 5 divided by 2x minus 8 is equal to 26 divided by 32. Now I can do my means and extremes. I get 32x plus 160 equals 52x minus 8 times 26. 160 and 48. What, 208? So I subtract the 32, I'll get 20x. I add the 208 and I get 368. Divide by 20 and I'll get that x is equal to 1, let's see here, 36 divided by 2, 18.4, 18.4. And so x is equal to 18.4. That means this one is 23.4 and this one is 36.8. 36.8 minus 8 is 28.8. Woohoo. I solved it anyway. I do appreciate the fact that when you guys send me information, you're telling me that you're in geometry. It does help me find things quicker. Although if you ask the right questions, I probably knew you were in geometry. Section number helps a lot of times because then I can look you up in my gradebook and make certain I'm answering your question the way you need to hear it. If you have any questions, feel free to come to tutoring on Tuesday or Wednesday or Thursday. I will look forward to seeing you there and in Class Connect. Talk to you next time.